Alright, so this is uh, Geometry, Chapter 8, Section 1, Pythagorean Theorem and its Converse. So, hopefully you guys have seen the Pythagorean Theorem before. Uh, and you guys have, and if you've forgotten it, it's understandable. And hopefully you can refresh your memory. So the Pythagorean theorem says this, and this applies to right triangles. Alright. Only, y'all. Only applies to right triangles. And it says this. I have a right triangle. We're going to do some definitions first. If we have a right triangle, that means that we have a triangle with a 90-degree angle. The side opposite of the 90-degree angle, we call that the hypotenuse. We'll also use the symbol C to denote the hypotenuse. We also have the other two sides of the hypotenuse. We're going to call those guys the legs. Usually the shorter side is called A, and then the larger side, or the bigger leg, is called C. Right, they're both called legs, or mean B. The short leg is called A, the long leg is called B, and then the hypotenuse is C. Okay, these are all parts of a right triangle. And what the Pythagorean theorem says is that the sum of the square of the sum of the legs is equal to the square of the hypotenuse, meaning a squared plus b squared equals c squared. A squared plus b squared equals c squared. Okay. The Pythagorean theorem. If a triangle is a right triangle, then the sum of the square of the legs is equal to the square of the length of the hypotenuse. I'm not going to write all that down. But that is the Pythagorean theorem. Alright, so we have certain things called Pythagorean triples. And these Pythagorean triples are numbers that occur when you do a squared, b squared, c squared, and they tend to give you whole numbers as a result. So one of the more famous Pythagorean triple is called 3, 4, 5. Why? Because 3 squared plus 4 squared is equal to 5 squared. So that's 9, that's 16, that's 25. 25 equals 25. So this is a Pythagorean triple. They're usually whole numbers. A lot of times when we do Pythagorean theorems, we're going to have a lot of radical forms or a lot of decimals. But these guys tend to be whole numbers. And they occur very commonly in right triangles. So it would be a good idea to memorize a couple of them I would definitely put to memory for right now 3, 4, 5. I mean, it's the easiest one to remember is 3, 4, 5. Other Pythagorean triples, so we have the 3, 4, 5 Pythagorean triple. We have the 5, 12, 13, 8, 15, 17. And then we have 7, 24, and 25. Okay, so these are the common Pythagorean triples. I guarantee you're going to see that a lot. And you see this a lot as well. So it would be good to sort of note that and put it to, memory. All right. The first question. Oh, one other note about Pythagorean triple. Let's look at the 3, 4, 5 for a second. There also, you can sort of set up I want to say proportion like scenario. So not only does the 3, 4, 5 work, but its multiples work too. Like, what do you mean by multiples? So instead of saying 3, 4, 5, I'll say 3x, 4x, 5x. And let's say that x equals 3. So then this would be renamed to 3 times 3 is 9, 15, and 12. And this works. So if I was to do 9 squared plus 12 squared equals 15 squared. Since 3, 4, 5 is a Pythagorean triple, any multiple of that 3, 4, 5, in this case I did a multiple of 3, also works. So 9 squared is 81, 144, 15 squared is, what is 15 squared? 225? 225. And 144 and 81 is 225. So any multiple of the Pythagorean triple works. So that's a neat, handy thing if you recognize Pythagorean triples right away. Alright, got it. 1A. Alright, so we have a leg of 10 and a leg of 24. They want to know what the hypotenuse is. So remember, a squared plus b squared equals c squared. So this is going to be 10 squared plus 24 squared equals c squared. Well, 10 squared is 100. 24 squared is 576. So this is going to be 676 equals c squared. I'm going to square root both sides because I want the square to go away. And the square root of 676 is 26. So the hypotenuse is 26. Does it form a Pythagorean triple? Yes. So if I put 24 over here, if I was to divide all of these guys, I'm sorry, 26. If I was to divide all these guys by 2, 10 divided by 2 is 5, or I could say 5 times 2. 24 divided by 2 is 12, or 12 times 2. And 26 divided by 2 is 13. 13 times 2. And if you look here at the common Pythagorean triples, we have a 5, 12, 13. 5, 12, 13. And it's multiples. And in this case, it's a multiple of 2. We've doubled that size. So, yes, it is a Pythagorean triple. Usually whole numbers as your answer for triangles tend to be a Pythagorean triple. Alright, so Here we have hypotenuse. Okay, what is the other leg? For this one, we have a hypotenuse of 12. We have a leg of 6. We want to know what this other guy is. So a squared plus b squared equals c squared. They give us a squared. And I don't know if this is the shorter leg. I'm just doing it because it's given to me. 6 squared plus b squared equals 12 squared. So that's going to be 36 plus b squared equals 144. I'm going to subtract 36 from both sides, and I get 108. I'm going to square root both sides. Notice it says to express your answer in simplest radical form, meaning I'm going to have a square root answer. So square root of b squared is b, and the square root of 108 is not a perfect square. So I'm going to have to factor it. Let's see, 108 divided by 4 divided by 9. Okay. 9 times 4 is 12. Mm-hmm. It's 36. Alright, so I'm going to factor out to 36 and 3. Is that right? Yeah. 36 and 3. And I'm going to square root both of these guys. And square root of 36 is 6, and the square root of 3 is just the square root of 3. So b is 6 times the square root of 3. If you're wondering where I got 36 from, when I think of this, I first divided it by 4, and I got 27 over here. I knew that I could pull out another perfect square because I know 9 times 3 is 27. So I have 2 perfect squares. I have a 9 and I have a 3. So what I did was I multiplied the 9 times, or 4. I multiplied the 9 times the 4 to get my 36, and then I just threw the 3 in there. Try to pull out as many perfect squares as you can, if you can do that in your radical form, and then multiply those perfect squares together, and that tends to get you your answer. Okay, finding distance. The size of a monitor of a computer is the length of the diagonal. And if you want to buy a 19-inch monitor and it has a height of 11, what's the width? So if we have a computer screen, what they're telling you is, when we say how big the computer is, it's really based off of the length of the diagonal. So they're telling me that the diagonal is 19 and that the height is 11. So what is this guy? Let's call you B, buddy. Alright, so a squared plus b squared equals c squared. They want you to round to the nearest tenth of an inch. I don't do tenths, I do hundredths. So it's 11 squared plus b squared equals 19 squared. 11 squared is 121. B squared. Mm-mm-mm. 19 squared is 361. Subtract 121 for both sides. And b squared is equal to 240. Square root both sides. And this guy's width is 16.49 inches. The converse of the Pythagorean theorem. All right, so the Pythagorean theorem, put P. All right, the Pythagorean theorem says that a squared plus b squared equals c squared. Okay, the converse of that of the Pythagorean, I should have just said Pythag, is these guys switch. If the square of the hypotenuse in a right triangle is equal to the sum of the square of the legs, then they are a right triangle. If the sum of the square of the length of two sides is equal to the square of the length of the third side, then it is a right triangle. So they're saying in a right triangle, if this works, then it's a right triangle. So think of it this way. Actually, I give you bad information. If it's a right triangle, then a squared plus b squared equals c squared. Okay. The converse is if a squared plus b squared equals c squared, then it's a right triangle. Okay. So identifying right triangles. If they give me three lengths, here they give me 16, 48, 50. Is it a right triangle? Let's find out. Since this is the biggest side, this will always be my hypotenuse. Hypotenuse is always the biggest number. So this means that these two guys are my legs. So it's going to be a squared plus b squared equals c squared, which is 16 squared plus 48 squared equals 50 squared. So 16 squared plus 48 squared, that gives me 2,560. And then 50 squared is 2,500. So they don't equal each other. So it's not a right triangle. Okay. Let's see. Theorem 8.3. So if they're equal, it's a right triangle. If they're not equal, then it's not a right triangle. Theorem 8.3 says if the sum of the square of the length of the longest side of a triangle is greater than the sum of the length of the other two sides, then it is obtuse. So if we have a triangle, and it's not a right triangle, just a right triangle, the largest side, we'll call it C. The smallest side, we'll say this is the smallest side, we'll call it A. And the second smallest side, or second largest, depending on your point of view, is B. If the largest side, when I square it, is greater, it's greater than the sum of the square of the next two sides, then it is obtuse. Alright, so if I square the largest side and it's greater than the square of the two other sides, then we have an obtuse triangle. Theorem 8.3. Conversely, when we talk about Theorem 8.4, let's say we have a triangle, but instead of it being greater than, it's less than. If c squared is less than a squared plus b squared, then we have an acute triangle. Okay. All right. So is an obtuse right or acute triangle. We have 7, 8, and 9. So 9 is my largest side, so it's going to be 9 squared, and we'll see if it equals less than, greater than, equal to. I'm just going to put equal there as a placeholder. 7 squared plus 8 squared. That's 81. That's 49. I already see where this is going. That's 64. So we have 113. So 81 is less than 113. And since it's less than that, then we say it is an acute triangle. It's so cute. Alright guys, that is that section. Hope you have a great rest of your day.